welcome back to Engineer's Workshop. We're rolling right into part 2 of making the hold down brackets for my son's power steering rack and pinion assembly in the Spitfire. So it's 2 rectangular chunks of steel. We roughed those out, hogged them out of a big block that I had. Now we get to put all the interesting features in it. So basically, if you can tell from this view, we've got a scallop and then a clearance scallop behind it. And there's fairly good sized chamfers on the lead ends of both of those. And then around this small end, really big chamfers. So I added a feature here. I took a measurement from the theoretical sharp corner down. I'll tell you about why I did that in a minute. 2 hold downs, 13-30 seconds, coming very close to the bore of this item here. Let's go over and take a look at the blocks and show you some opportunities. There's not many opportunities for combining operations or streamlining this process, making 2, but I've got a couple things we can do to make this a little quicker. So let's take a look at the blocks themselves. I drew the features on the sides of this thing so I would kind of know what's going on. And my first thought for combining operations would be to put these together and machine it in one go instead of doing things individually. Now, of course, if you didn't have a rotary head mill, to do this feature, which has a scallop here, and then all of those internal chamfers, you would have to set up each block on a rotary table, and you would have to move your table into the cutter, swing it around, and come out, and do that for every pass until you were at your depth. With the rotary head mill, you know, I can clamp those together and I could offset my head and I can walk that profile and just keep increasing the depth until I'm, you know, at the depth I need. So initial thought, clamp them together. Then I thought, well, you know what, if I separated them a known distance and I took a 1-inch gauge block and I separated these guys by, let's say, 1 inch, I would have an open cavity for chips to get evacuated and where I could plunge down and increase my depth. This thing has to be 1.25 inches deep on a minimum of 1.25 inches deep on the small one. And so I will go just beyond that, and then when I flip the blocks over, same deal, have my 1-inch gauge block separating them. I just have to plunge in and do the larger cut, which is, I don't have my, oh, there's a dimension, 1.875, and then a chamfer on each one. So I'll control my depth from that surface to that surface, which is 0.75 with the larger cut. So let's go get this thing set up in the mill, and let's crack on, as the brothers in the UK say it, with the rest of these operations. My first setup, I'm actually going to clamp the blocks in the vise lengthwise. That way I can sit on my machined edge of the vise and the drill is free to poke down through between them. And I will zero up on the edge of one and the front face. So for my zero reference, my hole locations will be 0.375 and 2.125 in that direction. And in this direction, with the 1-inch gap, 1.375 and 3.125. These will be taken up to a 0.406. Yeah, that just wants to start going in there. Okay, so right now I've established that point as 0, 0. Minus 2.125, comma 1 is the location of the first hole. This is not the first time I've done this. Try a little bit more aggressive feed. That was a thousandths feed. This is a 1.6 thousandths feed. Looks like we were better off where we were. Switching over to a drill bit that has a stepped shank. That last one was not particularly well sized for the collet, and I had to really crunch up on it in order to get it to grip. This is going to be a little bit on size. Unfortunately, the drill's not long enough to go all the way through the material. So I'll drill about 1.5 inches deep, pilot, and then I'll switch over to the 406 drill and try to continue the rest of that without a pilot hole. I think I should be able to go the last 1/2 inch. Switching over to a China drill with a step shank and a hand grind. Actually drills pretty well. I can get it to focus. According to FS Wizard, I'm supposed to be running about a 2.7 thousandths feed and 725 RPM. So I increased my feed to see how it performs. I let too many chips get packed in there. Now going to re-zero my X. This time though, I'm going to make it halfway between the two blocks. So I'm going to take this dimension right here, snug against one block, and I'm going to move 1/2 inch and zero that. Okay, I locked my Y table at 1.125. So here's how I'm set up for the next operation. I've got the 1 inch gap between here. I've got the machine at 0. I need to traverse 1.188 in either direction. At that point, I swing the head around 180 and I just make a continuous loop. The cutter is a 1/2 inch, 1/4 inch radius, so to make a 5/8 radius scallop. I need to subtract the radius of the cutter, and my head offset is 0.375. I'm going to take a 30,000 step of cut, just a witness cut around to prove everything out. So offsetting my head, 100, 200, 300, 75. I want to lock that in. So there's my 180, and I'll be milling the front of this block first. There's my 30 thousandths. So I'm going to take it over to an X of 1.188. Swing 180, I should be left with about an 1/8 inch wide rib standing up. And I just repeat that with a cut on the other side. Now we just repeat that, except I think at this point I'm going to go with 1/4 inch depths of cut. Let's see how we can do. Switched back over to my original collet because it just runs truer for heavy cuts. I think what I'll do is I'll get the vacuum going, try to have 3 hands. Let me show you what I've done here. I've set my kickouts here, my table stops, so that the automatic travel will stop about a 1/4 inch shy of each end, and then I can hand dial up to the target on each side, but this way I won't accidentally overshoot it. So at each center I have to drop the cutter a 1/4 inch. I am currently a 1/2 inch deep. Next cut will be taking it down to 3/4. At this point I think I'm switching over to positive air blast to keep the chips out of the way. This will now be an inch deep. Okay, now if you can see in there, I'm an inch deep. Already beyond the length of the flutes of the cutter. I got to go one more pass, take that to just a little bit over 1.25 inches. That's really pretty cool. Do that on a manual machine or without a rotary head mill. I'm going to do one more operation before I break down this setup. It's not on the print, but I'm going to increase the offset of the head. Got my 45-degree chamfering tool. I'm going to put just a tiny little chamfer, 30 thousandths chamfer on that outer edge. I'll just bring the cutter down until it touches. And now I'll come down another 30. Manual feeding. A deep cut. Now, my theory is, got my DRO set for an X offset of 1/4 inch, which means the 1/2 inch cutter, when I'm touching this block, puts that face in the same place it was when I was machining the other side. This establishes my spacing, and if I simply lock this down, I should be exactly on top of my other profile that I just made. So this next profile has the same coordinates, it's just a different offset. Okay, so I have my offset, 0.6875 times 2 plus a 1/2 inch cutter diameter is 1.875. Same deal, walk it in, swing around, and a 30 thousandths deep test cut. There's my first pass, 1/4 inch deep. This side is exactly 3/4, so it's 3 passes. Final cut, an additional 1/4 inch, bringing the total to 350. This should break through to the other cut. I know this is going to look a little sketchy, but it is a better alternative to that chunk falling down in the path of the cutter, which happened on the other side. So I'm just going to put a little bit of tension on this, keep it away from the side that's cutting. The last internal feature is 150 thousandths chamfer on that edge and that edge. I'm going to do the top one first. I cleaned up a bit here and here so I can see exactly when I'm making contact. And let's do maybe, we'll do 100 thousandths on the first pass, and well, maybe we'll do 3 passes of 50. That'll just be a little easier. So first we'll establish when I make contact. So we have contact at 80 thousandths on the dial. 10, 20, 30, 40, 50. We're going to use the same coordinates. I just increased the offset of the head. Walk 3 circles around this orbit, this elliptical orbit. Second 50 thousandths cut. I'm going to increase the RPM of the cutter a bit. Gonna do 40 and then a 10,000th cleanup. It's just a lot of material being removed on such a small cutting diameter. Alright, so what happened here is it stopped cutting into the arc and I thought something moved. But I was at the wrong coordinates. That should be 1.188. So as I was going into the arc, now we should hear a consistent cut all the way around. There we go. Final 10. I've reset things to reach down in and get that inner edge. I'm going to climb cut this. I ran a pass backwards on that. Got a better finish climb cutting. So let's climb cut the inner groove. I've had issues climb cutting with a chamfering bit on big diameters because it tends to pull the head away, you know, into the cut, but this one is a small enough radius, it should be fine. Last cut's going to bring us awfully close to the holes here, but that's what it looks like on the print. Final pass is a 10,000th cleanup cut, and we have the room for it. Final operation, I switched over to the big vise just so I can get more grip, and I added paper in here, which is supposed to help because I do not have a tilting table. It's on the list, but I have never been able to find one decent one at a decent price. So these chamfers on these three edges, they're all just clearance, nothing critical about the angle. So I set the first block up with just a speed square and the angle between them with the speed square because I could not get the speed square in with my other vise. So these two top edges will be done first, and the dimension is 0.309 from the peak, from the point of contact. So let's get a little closer here. I've got my cutter and the quills zeroed. I'm going to bring it down so I make contact. I think I am just touching. So let's come down 309, 100, 200, 300, 9 thousandths. I think I'll do these in maybe 2 passes. I'll just be cranking the y-axis here. Let's be smart and push the burr into the part on the next one. Now, because the blocks aren't square, I do have to reset the height. Theoretically, my height should be the same here, but I'm going to find it again by raising the knee. I think I'm just whisking the surface. You can see they look a little bit wonky, the amount of material left exposed here and here. Here's why. That one lifted up as I was adjusting it. So the chamfer is bigger than it was intended to be. Good thing it's just clearance. Well, there we have it. 2 hold down clamps for the Spitfire power steering mechanism, the rack and pinion. A bit disappointing to screw up the part visually on the very last cut. One of those deals where when the vendor calls you and says, hey, we did this, can you still accept them? You know, as an engineer, I typically say, yeah, if it doesn't affect the function of the part, go ahead and ship it. But you tuck your tail between your legs and learn from the mistake and try not to do it again. These are all just clearance for something, so these are going to be clamping that rack down. It's just a stamped steel housing, and these chamfers here are all clearance, so he'll be happy to get them, and he'll be able to move on with his assembly of the components on the frame. So I hope you enjoyed that. There was a lot of heavy cuts, heavy hogging on these to get them to size, and having the rotary head feature certainly did make this quicker than what it would take on a conventional Bridgeport, milling all these radii that just blended right into straight sections. So it was a lot of fun. Hope you enjoyed it. Back to you again next week with more projects. I hope you have a great Labor Day weekend. Till next time, stay safe.